The solutions of linear systems follow a certain pattern. Let's exhibit that pattern with an example. Here's a linear system with two equations and four variables, x, y, z, and w. Let's construct the augmented matrix and put it into echelon form. Here's the augmented matrix. You can see the 2 and the 9 over here, and these are the coefficients up here with zeros filled in for the ones that are missing. Now, to put it into echelon form, we need to remove this 2 here, and we can do that by multiplying the first row by -2 and adding the 2 rows. That's what's specified here, -2 row 1 plus row 2. And since it doesn't change row 1, we copy row 1 first. And then -2 times 1 is going to cancel that when we get 0. -2 times 2 is -4. -4 plus -1 is -5. We expect a -5 there. In fact, we do see a -5. Then -1 times -2 is 2. Plus -2, we get the 0. That 0 means the 5 doesn't change. And we have a -4 here. Plus 9 is 5. Okay, once we have echelon form in terms of matrices, we need to translate it back to equations. The second row, or the second equation, the second row produces the second equation, and that's -5y. This is x column, y column, z column, w column. -5y plus 5w equals 5. We can solve this for the leading variable y in terms of the free variable w. And we get, canceling the 5s, y equals -1 plus w for the second equation. Now looking at the first row of the first equation, we can read that off as x plus 2y minus z equals 2. That's what's written here. And we can solve that by using y equals -1. We can replace the leading variable y here with -1 plus w. So we simplify this to get x, the leading variable, in terms of the free variables z and w is 4 plus z minus 2w for the first equation. Okay, so we have these two equations, and what we'd like to do now is put them into vector form. So if we include z equals z and w equals w, so the first row here is x, the second row y, the third row z, the fourth row w. So if we read across here, this says x equals 4 plus 1 times z minus 2 times w. Well, here's x equals 4 plus 1 times z minus 2w. Those are the coefficients there. The second row for y is y equals -1, no z, plus 1w, and that's exactly what you have here. The third row is z equals z, no w, and the fourth row is w equals no z and w. So this, if we look at the rows, we recover all the equations up here, okay? So this is the solution, and we want to look at it and see how it exhibits the general pattern I mentioned at the beginning. Well, there's a constant vector here, meaning it has no free parameters in it. It's going to be called the particular solution. And then we have a part over here, one vector for each of the two free variables. It's a sum of terms like this, and it's going to be an example of the general form of the solution of any linear system.